This video is going to talk about fractions, ratios, and percentages. In this video, we're going to talk about how many boys are in a class, how many girls are in the class, and for the purpose of making a ratio, we are going to make the assumption that that is the entirety of the people in the class, even though that doesn't always happen. So they want us here to fill in the number of boys, girls, and children if the girls plus the boys equals the number of children. So how many boys would there be in this setup? Well, there's 8, so we'd put an 8 there. How many girls are there? Well, there's 7. And if the number of boys plus the number of girls equals the number of children, that would be 8 plus 7, which would be 15. What about if there are 6 girls in a class of 20? Well, then I know that there are 6 girls, and I know that there are a class of 20, which tells me 20 students. Now, if girls plus boys equals the class, then we know that there are 20 number of students, take away the number of girls, which would leave 14 not in that set. What about the number of boys in a class of 30? Well, the class is 30, the number of boys is 12, and if the only thing left is the number of girls, we would take 30 minus 12, and we would get 18. And what if there are 17 girls in a class of 28? Well, the class would be 28, the number of girls would be 17, and if the number of boys is all there is left, it would be 28 minus 17, or 11. Now we want to fill in some more information. If there are 6 boys and 5 girls, so 6 boys, 5 girls, and let's say that girls plus boys equals the number of children, which would be 11, what would the fraction of the girls be? Well, the fraction of the girls would be 5 over 11. 5 girls for every 11 students. What would the fraction of the boys be? 6 boys for every 11 students. Do you see how this would represent our total? And then we would take either the boys or the girls to put in our numerator. Now let's go over here and let's start looking for the fraction of boys and girls. Remember, for the purpose of this math, we're assuming that boys plus girls equals the entire class. So we have 3 boys and 4 girls in a class. I'm going to make a column here for boys and for girls. Well, that's odd. Boys and for girls, so that we can have a space for our fractions. So what would the fraction of boys be for letter A? Well, there are 3 boys. How many total people are there? If we assume that boys plus girls equals total, 3 plus 4 is 7. And for the girls, it would be 4 sevenths. Now what about letter B? 7 boys and 13 children in a class. Well, the ratio of boys to children, or the fraction of boys, would be 7 to 13. If there are only girls left, then I would take 13 and I would subtract 7 away, and I would know that there are 6 girls in this situation. 8 girls and 19 children in a class. Well, the fraction for girls would be 8 over 19 total. If boys are all there are left, then that would be 19 minus 8, which is 11 19ths for the boys. Notice that in these problems, these two numbers will equal the denominator. The numerators will equal the denominator. If the ratio of boys to girls is 1 to 2, that tells me there's 1 boy for every 2 girls, which tells me there would be 3 people total in this circumstance. So Ratio of boys is 1 to 3. Ratio of girls is 2 to 3. If the ratio of girls to boys, is 2 to 3, that means there's 2 girls for every 3 boys. So again, putting our fractions back here, we would know that the fraction of girls would be 2 to how many? 5. And the fraction of boys would be 3 to 5. What if the ratio of boys to girls, and we will continue on with this. Let's determine the number of girls and boys in these classes, if there are only girls and boys that make up the students. There are 30 children in class, and 3/5 of them are girls. So here's what I know. I know that 3/5 of the people are girls. I know that there are 30 total children in the class. So what I'm going to do is I'm going to figure out how many girls would there be if there were 30 people in the class. I know that 5 times 6 is 30, so 3 times 6 would equal 18. There would be 18 girls in this class. How many boys would there be in this class? Well, if there are 18 over 30 girls, and if all that's left are boys, that would mean 30 minus 18 would be 12. What if there are 36 children in a class and 4/9 of them are girls? Well, if 4/9 of them are girls, I want to know the fraction for if there are 36 children total. Well, 9 times 4 is 36. 4 times 4 is 16. So 16 36ths are girls. If there are only boys left, how many boys would there be? Well, 36 minus 16 would be 20. And we're subtracting because we're assuming that there's only girls or boys in these classes. Not always true, but that's what we're assuming for the purpose of this problem. If there are 21 children in a class and 4/7 of them are boys, remember, this means 4 boys for every 7 kids, and I want to know what happens if there's 21 students in the class. 7 times 3 is 21. 4 times 3 is 12. So there are 12 boys in the class of 21. How many girls are there in the class of 21 if there's only boys and girls? Well, 21 minus 12 is 9. So we can see that our numerators here would tell us the number of girls and boys. If we say there's 9/21 girls and they ask for what is the number of girls, that's going to tell you that there's not even one entire girl in class. If they ask for the fraction, this would be the answer for the fraction of girls, which is why it's always important to read carefully. If there are 18 children in a class and the ratio of boys to girls is 7 to 2, we're going to go ahead and we're going to read this carefully so we can see the differences in these problems. They all say that there's 18 children in the class. We can see this. The first question asks for the ratio of boys to girls. There are 7 boys to 2 girls, and we can see that here. The second question is talking about the ratio of girls to boys. There are 2 girls for every 7 boys. The third question is asking for a ratio of boys to girls, telling us that there are 2 boys for every 7 girls. Look this over carefully and find the one of these that are different from the other two. If you said letter F, you would be correct. Letter D says 7 boys. Letter E says 7 boys. Letter F says 7 girls. Letter D says 2 girls. Letter E says 2 girls. Letter F says 2 boys. That's why it's always important that you read carefully. Letter G, there are 30 children in the class and 60% of them are girls. So if there are 30 children in the class and 60% of them are girls, well, 60% might be helpful to use that as a fraction instead. That tells me 60 over 100. So if there are 100 girls, 60 of them are, if there are 100 kids, 60% of them are girls. But that's a big number, and I don't want to deal with that big number. So I'm going to simplify it. It's going to become 6/10. That looks easier. So I know that there are 6 girls for every 10 kids. But what if there are 30 kids? Well, if there are 30 kids, 10 times 3 is 30, 6 times 3 is 18. So 18% of them are girls. Now, what if we would have found, we could have also found 10% of 30. 10% of 30 is 3. And we could have multiplied 3 times 6 to get 18. If there are 45 children in the class and 40% of them are girls, again, 40% is the same as 40 over 100. It's a big number to deal with. I'm going to go ahead and I'm going to simplify that down to 4 over 10. But the problem is I want to get to change 10 into 45. 10 doesn't change into 45. So I'm going to see if I can simplify this even more. 4 divided by 2, 10, they can both be divided by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Now, if there are 45 children total, 5 times 9 is 45. So 2 times 9 is 18 girls. We could have also taken 10% of 45, which is 4.5, and we could have multiplied it times 4. We could have added it up we could have added it up 4 times. So we have a baseball player who got a hit 2 out of every 3 times at bat. She was at bat 9 times. How many hits did she have? Well, we know that she was successful 2 out of every 3 times. She was actually at bat 9 times. 3 times 3 is 9. 2 times 3 is 6, which means how many hits did she have? She had 6 hits. Let's talk about the ratio of red marbles to green marbles down at letter B. The ratio of red marbles to green marbles in a jar is 4:11. In the same way that in previous questions we were assuming it's only girls and boys in a class, we're going to assume there's only red and green marbles in this situation. So the ratio of red marbles to green marbles is 4:11. 4 red to 11 green. Remember that order matters. If there are 60 marbles in the jar, they want to know how many green marbles are there. Well, that means that I'm going to be making a ratio of green, that would be the word green in another world, to total. Well, we know there's 11 green, but how many total marbles are there? Remember that red plus green equals total in this case. So 4 plus 11 is 15. If there are 60 marbles in the jar total in the actual amount, I need to know how many times does 15 fit into 60. Well, I know that 15 plus 15 is 30, and 2 30s make 60. So I'm going to be multiplying times 4. And 11 times 4 is 44. So there are 44 green marbles in that jar. If there are 2 apples in a bowl for every 2 oranges. If there are 15 fruits in the bowl, and we assume that there are no other fruits in there, like grapes, that would really throw us off. How many apples are there? So we know 2 apples for every 3 oranges. Together, this makes 5 fruits in this ratio. We know that there's 15 fruits in this bowl. We want to know how many apples are there. Well, the fraction of apples in the bowl is 2 apples for every 5 fruits. 5 times 3 is 15. 2 times 3 is 6. There are 6 apples in that bowl. I hope that you have an absolutely fantastic day. You've got this. I believe in you.